Hello everyone, welcome to Nrcm. This is Shravani and I'm going to explain about operating system of Unit 4 and today's topics are Pallades Anomaly and trashing. First, I just want to discuss about this Pallades Anomaly. So this, like in the previous videos, we have discussed about page replacement algorithms. So I think you all remember that the number of page faults should be either decreased or remain constant on increasing the number of the frames in the main memory. So I just wanted to show it through the diagram. See, when we will be replacing the pages, so if this memory, if it is been like divided into different frames, so it is divided into different frames and this it is full, and if any of the new page want to be inserted into the new frame, any of the new page want to be inserted into the frame, then what happens, this any of the page, it will be swapped outside and then next page will be inserted into the frame. Yes or no? So like here, so I think you can consider like, so many of them has questioned me like, so why couldn't we like increase the size of the memory? So if we increase the size of the memory, so that what happens, if any of the new frame is entering into the if any of the new frame is entering into this main memory, so that the page can be fit into this frame. So this is what we normally feel. So here, so what happens, the number of page faults at this condition, what happens, the number of page faults should either decrease or they should remain constant on increasing the number of the frames in the main memory. So this is the graph, these are the frames, and these are the frames and these are the page faults. Okay, so they should be either decreased, so this is the page fault and this will be decreased as the increase of the number of the frames in memory. As we increase number of frames in the memory, this page fault will be decreased. So but sometimes this is normal funda, this is what, okay, but sometimes what happens, there will be some unusual behavior. Like, so what happens, sometimes even though if we increase the number of the frames here, so what happens, the page fault will be increased. So the page fault will be going on increased, okay, or increase or else the number of page faults are increased more and more for each time. So this is called as an unusual behavior will be observed, and this is called as Pallades anomaly. So normally the Pallades anomaly, it is a phenomenon of increasing the number of page faults on increasing the number of frames in the main memory. Okay, so and this Pallades anomaly, so it will be normally, we can see this Pallades anomaly in first in first out page fault replacement algorithm. Okay, so if you want, you can try with this example like 3210. So you can try with this. So this is the reference string, and there are 4 frames, and I have explained in the previous class like how to solve this first in first out. So first you need to include all the reference strings, that is page faults here, like 3, 2, 1, 0, 3, 2 and so on, and frames are like 1, 2, 3, 4 frames will be there. So first you need to, this 3 will be fit into this first frame, next this will be continued, and next 2 will be fit in the second frame, and next 1 will be fit in the third frame, and next 0 will be fit in the fourth frame. And coming to the 3, so you need to replace the frame. So which frame you need, or which page you need to replace, like you need to replace the page, like whichever the page is like mostly used, that page should be replaced. Okay, so you just try with this with 3 frames and one with 4 frames also. So the if you try with the 3 frames, so you'll be getting 9 page faults, and if you try with the 4 page frames, then it produces the 10 page faults. So okay, this occurs only in first out page replacement, and also sometimes it might occur in random page replacement algorithm, and it might occur in second chance algorithm also. So algorithms whichever they suffer from the Pallades anomaly, that doesn't mean that always the number of page faults will increase or increasing the number of frames in the main memory. So this unusual behavior is observed only sometimes, not every time but sometimes. So normally, like why the algorithm will suffer from Berardi's anomaly. Like an algorithm that suffers from Berardi's anomaly, if and if it does not follow stack property. If it does not follow the stack property, then it will follow. Then the algorithm will suffer from the Berardi's anomaly, and the algorithms that follow the stack property, they are called as stack-based algorithms. Okay, and stack-based algorithms, they do not suffer from the Berardi's anomaly, and this is because these algorithms, they assign the priority to a page for replacement that is independent of the number of frames in the memory. So, and next, this is the example of the Berardi's anomaly, and as I explained, so only if you just try with this first in first out first in first out example, page replacement example with 3 frames as well as with the 4 frames, and you will be getting the page faults as well. So next, moving to this concept is, next is trashing. So first of all, what is trashing? So if the process is spending more time, if the process is spending more time paging than executing, is said to be trashing. So in other words, like it means that the process doesn't have enough frames to hold all the pages for its execution. See, suppose if there are no enough frames in this page. So consider if there are no enough frames, doesn't hold enough frames in its pages. So like suppose if the process doesn't have enough frames to hold all the pages in its execution. So see, if this is the process, it doesn't have enough space to hold all the frames in its pages. So what happens, we will be performing the swapping. So if the new page is arriving, so what happens, any one of the page within this frame, it will be swapped out, and next this new process will be swapped into the new frame. So this is normally, in this way execution will be happening, but sometimes what happens, these pages will be required in the near future, which have to be swapped out. Okay, so normally in multi-programming there can be a scenario when the system spends most of its time like shuttling pages between the main memory and the secondary memory due to frequent page faults. This behavior is particularly, it is known as the trashing. Okay, next, a process is said to be trashing if the CPU spends more time in serving page faults than executing the pages. Means, I'm repeating again, if it spends more time in serving page faults than executing the pages. So this leads to the low CPU utilization, and the operating system in turn tries to increase the degree of multi-programming. So like for example, consider there are 3 processes P1, P2, P3. So P1 is having 20 pages and it needs 5 more pages to execute, execute with the demand paging. Next, P2 has already 16 pages and it requires 4 pages. Okay, and P3 has already 12 pages and it requires 4 pages more. Let's say we have main memory that can hold only 12 pages, and the number of frames allotted to each process is based on its size. So P1 gets 5 frames to store 5 pages, P2 gets 4, P2 gets like 4 pages, and P3 gets like 3 frames to store. So what will be the degree of multi-programming? Anyone can guess? Like the degree of multi-program will be 3, I think. So the degree of multi-program will be 3. So like if we notice here, P1 and P2 get the required number of the pages. And what about the P3? And if P3 doesn't get the necessary number of pages to run, then here the page fault will be lost. It might be raised. So the necessary number of pages, that the process cannot run with any space we provided, even if we do paging. Okay, so this is all. So what might cause the thrashing in operating system is like, if we are having, as I discussed in the previous example, high degree of multi-programming, so it will cause thrashing, and less number of frames which are compared to the processor's requirement, so it causes thrashing, and process scheduling scheme which swaps in more process when CPU utilization is low, so it causes the thrashing. And next, coming to the so if you think how to overcome this thrashing, so as you can see, like degree of multi-programming, and has the CPU utilizations. So this causes here at this particular point the trashing is good. So if you want to handle trashing, like you can go for the working with set model, and you can go with page fault frequency. So with this we can overcome, or these are the techniques we can overcome to handle the trashing. And I hope you all understood what is trashing and what is Melodies anomaly. And I will be continuing with the next video. Until then, thank you.